Hello everyone, my name is Deepak Shekhar. Welcome to the session VMware Cloud Director on VMware Cloud Foundation. We have seen VCD and VCF, but today we are going to discuss more about how to deploy VCD on VCF. You can visit my blog virtume.in for more technical details on cloud and virtualization. The agenda for today's session is we will talk about the VCF architecture and different management and workload domains, a small introduction to VCF networking, and then we'll talk about different deployment options available on VCF. We would cover vCloud Director overview and then vCloud Director on VCF and different deployment models of VCD on VCF. With the VMware Cloud Foundation, you will get all the benefits of a modern private cloud based on proven VMware software-defined data center architecture. This private cloud platform is the best infrastructure to host your traditional as well as cloud-native applications. You get a consistent, repeatable, standardized infrastructure. This reduces complexity and resolution time. VCF provides advanced automation that reduces errors and risk in many common tasks. Using standardized building blocks with automation means you can easily scale capacity when it is needed non-disruptively. Of course, these benefits go beyond the initial deployment, and that's because the Cloud Foundation makes it easy to stay up to date with security patches and software updates. With VMware Tanzu integration, all these benefits are extended to modern applications, allowing internal IT teams to deliver and easily maintain developer-ready infrastructure. Cloud Foundation is the best platform for your traditional and native applications. In order to discuss some of the topics in detail, it is important to ensure everyone understands the core concepts of VMware Cloud Foundation. This section provides a quick overview of these core concepts. Cloud Foundation has an automated deployment process known as Bring Up, which deploys a standardized workload-ready private cloud in a matter of hours. Here is a look at the automated deployment process of Cloud Foundation. Customer can use their preferred network, equipment, and topology. The Cloud Foundation deployment starts with just 4 vSAN nodes prepared with ESXi. Customers can review the pre-deployment checklist to ensure all the prerequisites are in place: networking, customer provided DNS, NTP, DHCP services, and so on. The next step is to deploy a VMware Cloud Builder appliance. This appliance contains all the required software and automation to perform the automated initial deployment of Cloud Foundation. Cloud Builder requires an input file containing customer specific deployment parameters, information such as product license keys, account credentials, networking naming conventions, appliance sizing, and so on. This allows the Cloud Foundation configuration to be pre-planned in advance and accelerate the deployment. This information gets captured in an Excel spreadsheet and referred to the deployment parameter sheet or a JSON formatted text file. Once this input file is uploaded into the Cloud Builder, a validation is performed. Cloud Foundation will test these inputs and provide recommendations on any changes which may be required before the fully automated SDC deployment. During the deployment, a vSAN-enabled cluster will be formed using the customer-provided vSAN ready nodes. NSXT will be deployed and configured for use. The best practice configurations are applied and all the management components VMs will be deployed, including SDDC Manager. Let's take a deeper look at the management domain and its components. The management domain is a 4-node vSphere cluster configured with vSAN storage and prepared for NSX. We see vCenter server, an NSXT instance, and the SDDC Manager appliance. SDDC Manager is unique to VMware Cloud Foundation and contains automation to create, operate, and maintain the private cloud infrastructure architecture. In addition to housing the management components, the management domain can also be used to run vRealize components. The vRealize suite of products can help Cloud Foundation reach its full potential as it contains tools such as vRealize Login Site for centralized log file for auditing and troubleshooting, vRealize operations, monitoring of capacity and performance, vRealize automation to deploy application deployments to your new private or hybrid cloud. The management domain may also be used to house customer applications. When deployed in this way, we refer to this as a consolidated deployment architecture. This architecture is good for small edge deployments or a lab proof of concept testing. Many customers choose to separate the management components from customer applications, which is VMware best practice. This refers to a Cloud Foundation standard architecture software. Next, we will look at how to separate management from customer domains. Workload domains can be created as dedicated logical sets of infrastructure designed to run customer applications. Using SDDC Manager, administrators can add more hosts to the Cloud Foundation inventory to create a workload domain. A workload domain is a logical set of infrastructure designed to run customer applications. VCF supports heterogeneous hardware configurations. Customers can right-size hardware at a per cluster level for the application they intend to run. This allows general purpose hardware to be used for test and dev environments and more powerful hardware for key production applications to cater to specific requirements such as large memory configurations, faster CPU and GPU offload, virtual desktops, or machine learning applications. When first workload domain is created, a new vSphere cluster with a dedicated vCenter server is deployed along with a dedicated NSX instance to unallocated capacity in the Cloud Foundation inventory. The vCenter and NSX management components are deployed to the management domain, allowing for management and workload separation. Customer applications can then be deployed within the workload domain. Here is an example of a second workload domain. Once again, Cloud Foundation automation deploys and configures a dedicated vCenter server which would reside in the management domain. The customer can then choose to share the existing NSXT instance from the first workload domain. Create a new instance for networking and security separation if desired. NSXT edges can be configured within any workload domain or cluster for access to centralized networking and security services, as well as configuring secure ingress and egress between the cloud foundation deployment and the data center. Cloud Foundation supports up to 15 domains, which includes the management domain in any Cloud Foundation deployments. There are many use cases for using workload domains. Workload domains can be used as a way of allocating infrastructure for different business functions, separating application types, or perhaps separating the license features. Workload domains are a cornerstone component of Cloud Foundation. They can be independently created, scaled, lifecycle managed, or deleted. Let's take a look at the standard architecture of VMware Cloud Foundation. The standard architecture is the default, rather preferred mode. With the standard architecture, the management workloads run on a dedicated management domain and user workloads are deployed inside separate virtual infrastructure domains. Each domain is managed by a separate vCenter server instance, which provides for scalability and allows for autonomous licensing and lifecycle management. And here is the consolidated architecture. The Cloud Foundation can also be deployed with a consolidated architecture. This design targets smaller Cloud Foundation deployments and special use cases. In this design, the management and user workload domains run together on a shared management domain. The environment is managed from a single vCenter server, and vSphere resource pools provide isolation between the management and cluster workloads. In a consolidated architecture, care must be taken to ensure that resource pools are properly configured, as the domain is shared by the management and compute workloads. As you add additional hosts to a Cloud Foundation system deployed on a consolidated architecture, you can convert to the standard architecture by creating a VI workload domain and moving the user workload domain VMs from the compute resource pool to the newly created VI workload domain. After moving these VMs, you may need to update the shares and reservations on the compute resource pool in the management domain. Cloud Foundation automates the deployment of NSXT as part of the bring-up process. Cloud Foundation configures 4 VLANs in the management domain. A host tab network is deployed, which is used to create an NSXT overlay network. Understanding Cloud Foundation network is key to planning and scaling the deployment. When VCF is first deployed from bring up, each host is configured initially with the 4 VLANs. 3 of these VLANs are deployed as VM kernel ports, which traverse the virtual distributed switch using familiar vSphere networking. The VDS is configured with load-based teaming to optimize the network flow. These 3 networks comprise of VLANs for management, vMotion, and vSAN, and are configured following the VMware best practices. The ESXi host management IP address and the core management components of the platform, including the vCenter server and SDC manager, are deployed to the management network. NSXT is deployed as part of the Cloud Foundation to enable software-defined networking and security. NSXT Manager is also configured on the management network and is deployed as a fault-tolerant 3-node cluster. The fourth VLAN is used by NSX to configure a host overlay. This host overlay forms the basis of software-defined networking. Cloud Foundation automates the deployment of NSXT as part of the bring-up process. Cloud Foundation configures 4 VLANs in the management domain. A host step network is deployed, which is used to create an NSXT overlay network. Let's take a closer look at the host overlay network and how it is used in a Cloud Foundation deployment. Each host within the VCF workload domain is connected to one another using NSXT host tunnel endpoints to form a full mesh between them. The taps on each host are configured with IP addresses on their own unique VLAN and serves as the on-off ramp to the mesh. The separate host step network is also known as the NSXT overlay network. The host overlay network is used to carry NSX overlay traffic between the hosts. Customers can start leveraging SDN immediately once the Cloud Foundation is deployed. NSXT Manager can be used to deploy logical network dynamically when they are needed. The logical segment tunnel through the NSXT host overlay over the top of the physical network or underlay. Being software defined, these logical segments can be quickly deployed and just as easily pulled out. Virtual machines and the container services can be connected to one another on these logical segments. Logical segments within the overlay can be switched and routed to one another using the software controls within NSXT Manager. This allows administrators to make networking changes dynamically, which are completely independent of the physical network. Here is the basis of software-defined networking. Let's take a look at the Cloud Foundation deployment option. VMware Cloud Foundation now caters to a very broad mixture of different deployment options to suit a large variety of different customer scenarios. Cloud Foundation can be deployed in its most simplistic form as a single site consisting of one or more workload domains deployed in a consolidated or standard architecture. Each workload domain can consist of one or more clusters. Cloud Foundation also supports fresh cluster deployments between two sites when used with the VCF. The management domain is stretched and the customer has the option to stretch additional clusters within other workload domains. From version 3.9 onwards, multi-instance management allows multiple VCF instances to connect via federation for aggregated visibility and ease of management. Moving on to the lifecycle management. Cloud Foundation makes lifecycle easy, especially compared to traditional 3-tier. The power to create complete pools of infrastructure on demand through workload domain provides IT teams with the ability to provision private cloud infrastructure in just a few clicks. However, infrastructure provisioning is typically not done on a frequent basis as it is traditionally disruptive and slow. Lifecycle management, on the other hand, is being done on a weekly basis, if not more often. Tasks like patching and upgrading can be a daunting task in the data center and Risk of configuration drift and human error can delay patching operations. And with the traditional three-tier architecture and a software stack on top of it, the dependency mapping between multiple hardware, software, and server vendors can leave operation teams planning the upgrades for weeks and even for months. However, with vCloud Foundation, available updates for all components are tested for interoperability and then built with the necessary logic for proper installation order, distilled down to an update bundle to be upgraded to the system. And all of this possible using the software-defined data center. This allows software-defined infrastructure to be lifecycle managed, patched, and upgraded as full entity rather than individual components and managing their support metrics. Cloud Foundation offers lifecycle management on a per cluster basis. Update bundles are validated and tested and then released in the VMware depot. In SDDC Manager, you will receive a notification showing that there is an update available for download that is applicable to your software deployment. You will review the updates and assess the criticality to remediate your environment. You can also determine the scope of the upgrade, such as ESXi or NSX updates, in addition to the workload domains to be patched. A pre-check can be run prior to completing an update, which checks to ensure the components being upgraded are healthy and optimal. The pre-check will notify the user of any potential issue before commencing the upgrade. Using this information, you can schedule the upgrade to occur immediately or in a specific change window. Finally, you will be able to monitor the progress or review the post-update report. All these automated updates are done in hours instead of weeks. Let's move on to VMware Cloud Director. VMware Cloud Director is VMware's flagship cloud service delivery platform for cloud providers. It is a cloud provisioning and management interface for any VMware-based environment, forming a cloud fabric that can bring any vSphere endpoint under its management umbrella. VMware Cloud Director has certain core capabilities: one-click deployment, multi-site management capabilities, multi-tenant operational efficiencies, Kubernetes support, workflow automation, tight interoperability with VMware's core stack, and more. The idea is, once again, to create a cloud service delivery platform from core VMware technologies. Most importantly, VMware Cloud Director is open and extensible with robust service integration capabilities. While interop with VMware is a strength, VMware realized that the growth comes from integration with the third parties, the likes of data protection vendors, automation technologies, security and networking companies, and more. Turnkey infrastructure services have always been the bread and butter for VMware cloud providers. But with the VMware Cloud Director, VMware want to help them up level to move to more profitable services, some of which I have listed down on the slide: cloud migration, hybrid cloud services, data protection services such as storage, backup, and DR, cloud operations and monitoring services, and among the most important in today's context, security and compliance. So VMware has a few testimonials from cloud providers, cloud provider partners across the world who have come the most trusted cloud partners in their respective countries. In general, VMware Cloud Director covers two main themes: networking and security updates, and more Kubernetes capabilities. Within networking and security, VMware has a long-awaited VF Edge services, completing the parity with NSX VF capabilities. Also, distributed dynamic firewall membership adds complete automation for providers to offer policy-driven security to customers. Lastly, data center group networking makes communication between Kubernetes cluster and VMs within the same org possible. As far as Kubernetes is concerned, uh, this release brings complete Tanzu support for Kubernetes Grid for vSphere and multi-cloud, particularly supporting multi-tenancy automation, making tenant isolation possible for Tanzu Kubernetes Grid for vSphere. Also, VCD Tanzu clusters can now be supported by Tanzu Mission Control SaaS service, making VCD a Kubernetes endpoint for hybrid environments. Lastly, vCloud Director has made some usability improvements, making searching and shortcuts easier to use. Moving on to the last topic of today's session, VMware Cloud Director on VMware Cloud Foundation. One of the questions that frequently comes up is, how can a cloud service provider utilize VCD and VCF in unison while fitting into VMware Cloud Provider program? Why VCF and VCD? vCloud Director does an incredible job with providing a multi-tenant layer to infrastructure and services. Cloud Foundation streamlines the instantiation and lifecycle management of a VMware software-defined data center, which includes compute, storage, networking, and security. In VCD terms, this would be considered as the provider VDC that extrapolates out to organization or tenant resource objects. What you're seeing in the screen is the visual representation of VCF with VCD. In VMware Cloud Foundation, Cloud Builder and SDDC Manager automates the deployment of management and workload domains. Management domain consists of vCenter servers, NSXT Manager, SDDC Manager, vRelay suite of products, and in this case, vCloud Director cells are also be deployed on it, and the workload domains are used as provider VDCs by the vCloud Director for its tenant organization. Each tenant gets dedicated resources, which is coming from the underlying VMware Cloud Foundation. The automated deployment and configuration of VCF helps the cloud service providers consume the resources and onboard its tenant organization. Let's take a look at some of the deployment models available with the VCD on VCF. The cloud provider can build their infrastructure using VCF and deploys the entire VCD stack on a VCF-based infrastructure. Both VCD management resources and tenant workload resources are deployed on VCF-based software-defined data center, configured in consolidated VCF architecture, and is ideal for very small environment. Using a standard VCF architecture, a cloud provider builds their infrastructure from a management cluster using VCF and deploy the entire VCD management resources on this VCF-based infrastructure. The tenant workload resources are deployed on other VCF workload domains. And cloud provider builds a dedicated consolidated VCF stack for a customer with just a VCF management domain where the Tenant workload this presides. This is ideal for customers who want to access the vCenter configured for VCD via CPOM. With that, right, let's move on to the recommended VCD deployment model on VCF. Placing VCD management components within a VCF management domain is recommended deployment model since it is quite easy and straightforward. This is because the VCF management domain with its cluster already exists as mandatory VCF component, hence minimal planning is required to deploy Cloud Director. The deployment model provides better resource efficiency as the VCF management domain consists of 4 or more hosts and it's usually bigger than the resources required for VCF management instances, thus allowing Cloud Director management cluster to consume the surplus resources of the VCF management domain in terms of VCD deployments. It is recommended to use vSAN file share for NFS transfer share and the NSX ALB to load balance the VCD cells. Right, with that, we have come to the end of the session. Thank you for watching and please share your comments. Thank you.